Hello, good morning.
Hello,
Hello, how are you?
I'm good today. Thank you.
Good. I think we have someone else with us as well today. Hello, there she is. Hello, Monica.
Hello,
Hello.
how are you?
Hello. Hi, how are you today?
I'm fine.
Good. Nice to meet you. My name is Andrew. This is my first time seeing you in class today, so it is very nice to finally see you. So, how is everybody doing this evening? Chloe, how are you doing this evening?
I just finished my job.
You just finished your job,
Yes.
and how was your job today?
Um, I'm very busy this week because we have graduation cele- uh,
Ceremony.
ceremony tomorrow online tomorrow,
Mhm.
and then in the morning, and then in the afternoon tomorrow in in tomorrow afternoon we have
Mm. Yep.
online and new
Hmm.
student.
Yep.
The
Newcomer. Yeah.
newcomer, um how to say it, just the introduction
Yeah. Exactly. Yeah. The instruction.
introduction ceremony
Mm-hmm.
in the afternoon, so it's very busy.
Mm-hmm. Mm-hmm. So you have a lot going on right now in your life.
Sorry.
You have there's a lot going on right now.
Yes,
Lots is happening. Mm-hmm.
yes, for this week.
Yeah, for this week. Yeah. So I assume you're probably very tired then.
Yes.
Mm-hmm. And Monica, how about you? How are you doing tonight?
I'm fine. Then I was very tired as well today
Mm-hmm.
because I have a 2 day workshop.
A 2-day workshop.
Two-day workshop. It
Mm-hmm.
starts from 9 to 6:30 online
Oh,
without
okay.
start without stopping. And tomorrow, before the end of the workshop, we need to have a test. Yeah, there's a series
Mm-hmm.
of required tasks.
Mm-hmm.
There's a series of tasks. Uh,
Mm-hmm.
we have to fulfill as the requirement of,
Yes.
of the end of the workshop, so that
Right.
I get the certificate. Yeah,
Mm-hmm.
it's a training workshop. Yeah.
Mm-hmm. Awesome. They're reading. Okay. All right. So for today, I would like to review just a quick video on earthquakes. That's going to be our topic of discussion today. Have you guys heard about earthquakes before? Do you guys know what earthquakes are?
Yes, it's often happened
Mm-hmm.
in Taiwan.
Mm-hmm.
Yes, and also in the east of Taiwan, there was a earthquake just happened yesterday in
Yesterday.
in Hualien. Then it is called dual earthquake or something.
Oh
And
my gosh.
yeah, it is quite strong according to the news. I didn't know about it.
Yeah, according to the news, yeah. Okay, well, on that note, let us look a bit deeper into why earthquakes are so hard to predict, and maybe we will learn more about why this happened the other day. Okay. Can everyone hear? Can you guys hear?
Yes, I
Yes.
can.
Yes.
In 132 CE, Chinese polymath Zhang Heng presented the Han court with his latest invention. This large vase, he claimed, could tell them whenever an earthquake occurred in their kingdom, including the direction they should send aid. The court was somewhat skeptical, especially when
Sorry, a second.
the device triggered on tell them whenever an earthquake occurred in their kingdom, including the direction they should send aid. The court was somewhat skeptical, especially when the device triggered on a seemingly quiet afternoon. But when messengers came for help days later, their doubts turned to gratitude. Today, we no longer rely on POTS to identify seismic events, but earthquakes still offer a unique challenge to those trying to track them. So why are earthquakes so hard to anticipate, and how could we get better at predicting them? To answer that, we need to understand some theories behind how earthquakes occur. Earth's crust is made from several vast, jagged slabs of rock called tectonic plates, each riding on a hot, partially molten layer of Earth's mantle. This causes the plates to spread very slowly at anywhere from 1 to 20 centimeters per year. But these tiny movements are powerful enough to cause deep cracks in the interacting plates. And in unstable zones, the intensifying pressure may ultimately trigger an earthquake. It's hard enough to monitor these minuscule movements, but the factors that turn shifts into seismic events are far more varied. Different fault lines juxtapose different rocks, some of which are stronger or weaker under pressure. Diverse rocks also react differently to friction and high temperatures. Some partially melt and can release lubricating fluids made of superheated minerals that reduce fault line friction. But some are left dry, prone to dangerous buildups of pressure. And all these faults are subject to varying gravitational forces, as well as the currents of hot rocks moving throughout Earth's mantle. So which of these hidden variables should we be analyzing, and how do they fit into our growing prediction toolkit? Because some of these forces occur at largely constant rates, the behavior of the plates is somewhat cyclical. Today, many of our most reliable clues come from long-term forecasting related to when and where earthquakes have previously occurred. At the scale of millennia, this allows us to make predictions about when highly active faults, like the San Andreas, are overdue for a massive earthquake. But due to the many variables involved, this method can only predict very loose timeframes. To predict more imminent events, researchers have investigated the vibrations Earth elicits before a quake. Geologists have long used seismometers to track and map these tiny shifts in the Earth's crust. And today, most smartphones are also capable of recording primary seismic waves. With a network of phones around the globe, scientists could potentially crowdsource a rich, detailed warning system that alerts people to incoming quakes. Unfortunately, phones might not be able to provide the advance notice needed to enact safety protocols, but such detailed readings would still be useful for prediction tools like NASA's QuakeSim software, which can use a rigorous blend of geological data to identify regions at risk. However, recent studies indicate the most telling signs of a quake might be invisible to all these sensors. In 2011, just before an earthquake struck the east coast of Japan, nearby researchers recorded surprisingly high concentrations of the radioactive isotope pair radon and thoron. As stress builds up in the crust right before an earthquake, microfractures allow these gases to escape to the surface. These scientists think that if we built a vast network of radon-thoron detectors in earthquake-prone areas, it could become a promising warning system, potentially predicting quakes a week in advance. Of course, none of these technologies would be as helpful as simply looking deep inside the Earth itself. With a deeper view, we might be able to track and predict large-scale geological changes in real time, possibly saving tens of thousands of lives a year. But for now, these technologies can help us prepare and respond quickly to areas in need, without waiting for directions from a base. Keep exploring the terrifying power of nature with this playlist.
Hi, Gary, if you're there. Okay, so Monica, are you still there? Chloe's back. Awesome. Okay, so hi, Gary. Hello. Okay. Oh, and he's gone.
Children? A child?
Chloe, did you were you able to watch some of the video as well with Monica and I?
Yes.
Okay, so based on what we saw in the video, who create where was the first device to test earthquakes created? You guys remember?
It's made by John Hen.
Yeah. Yep. Very good.
John Hang.
Mm-hmm. So what he said was that with a vase is where you keep flowers in a vase. He claimed that he could tell them whenever an earthquake occurred in their kingdom. And he was trying to help save lives by giving people a warning, right? Mm-hmm.
Yes.
And the courts, right? So the kingdom was skeptical. Okay? They were skeptical of his idea, right? They didn't believe him, right?
Adopt.
Sorry, Chloe, what was that?
Adopt.
The what?
Adopt.
Oh, adopt.
It's equal to.
Could you put it in the chat?
Okay.
Yeah, doubt. Yeah, exactly. Yeah, exactly. Very good. So skeptical and doubt are very close, right? Um they're very much the same, right? They mean the same thing. That's good. Good morning, Gary.
Good morning.
Good morning. How are you today?
I'm fine, thank you.
Thank you. How was your day today? I was just asking everyone earlier about their day thus far.
I just finished my another math class when I'm in the English class.
So you finished math class and now it's time for English class.
Yeah.
Awesome. Very good. That's good to hear. I'm glad. I'm glad you are here to join us today. It's very nice to meet you.
Nice to meet you.
Okay, so Gary, because you didn't get to watch the video, we're gonna go over what happened in the story. Okay?
Okay.
Okay? So we're learning a bit about earthquakes today. Do you know anything about earthquakes?
Yes, I can share that I heard about animals. They can feel uh, they can feel the earthquake earlier than people.
Mm-hmm.
And I saw my I keep I have a cat in
Yeah.
my home, and
Mm-hmm.
but my cat um he feel the earthquake
Mm-hmm.
at the same time
Mm-hmm.
at the same time with me, so
Mm-hmm.
I'm not sure if that is correct.
Yeah. Maybe your cat is more sensitive, right? He's more sensitive to the weather,
Mhm.
right?
Mm.
Does that make sense? He's more sensitive to the weather.
He always fe- feel as at the same time with me, so I think he is not really sensitive
Mm-hmm.
in the animal.
Mm-hmm. Does anyone else have any pets that feel storms happening or coming on? Monica, do you have any pets yourself?
No, I don't have any pets, but I
No
know
pets?
I do I know some animals do have the anticipation anticipation has the some animal have the ability to anticipate the coming
Mm-hmm.
of earthquake,
Mm-hmm.
such
Yeah.
as before the event the word of the earthquake, you may
Mm-hmm.
see the animals are very nervous and impatient. They may running on and off or something. Yeah,
Mm-hmm.
it's very clear, especially on the farm.
Mm-hmm. Mm-hmm.
And also maybe you can see uh, um, many ants, many ants
Mm-hmm.
before the coming of a rain or the earthquake.
Yeah, yeah, the coming of rain. Yeah. Gary, do you have any pets yourself?
I have some fish in my home.
You have some
And
fish?
I think they are so crazy. They always jump out of the water.
They jump out of the water. That's funny. What kind of fish are they?
It's just is small fish. That's
Just small fish?
yeah.
That's funny. Well, I have a cat. Um and I also have a little hamster as well. Hamster. Do you guys know what a hamster
Yeah.
is? Yeah.
Oh,
Um
guinea pig.
yeah, like that, or like a guinea pig. Yeah. Hmm.
Ceremony graduation.
No, just this part.
Ceremony.
Oh. Yeah, so anyway, I don't know why. Sorry, I don't know why it's not playing. Okay, so well, let's continue with the rest of the video. So, like Chloe was saying earlier,
Earth's crust is made from
Yes.
several
vast
jagged slabs of rock called tectonic plates, each riding on a hot, partially molten layer of Earth's mantle.
mantle. All right, because the Earth is made of different parts, right? Different sections of the Earth, right? So there's different layers of plates that move together. Right? So we're up here on this top part over here. And then as you get closer to the center of the Earth, right? There's hot molten rock in between, all in this section here. And where the molten rock is, that's where the earthquakes start, when the plates, they rock and move together, right? Gary, do you understand how earthquakes work?
Yeah.
Yeah.
It's the part of the ground and move and push the other off.
Yeah, exactly. They're kind of like having like a fight with each other, you know?
Yeah.
Mm-hmm.
But these tiny movements are powerful enough to cause deep cracks in the interacting plates.
Geologists use. So Monica was talking about this earthquake that happened the other day. Does anyone, Gary, did you hear about this earthquake that happened? Monica, what did you say it was called again?
According to the news, the earthquake, it was caused by a dual earthquake or something. Dual, that means they are two main earthquake, and they even say there will be many many other earthquakes followed. Yeah.
But do you know the name of the city where it happened?
Hualien.
Hualien. Can you put it in the chat? Can you type, if you type it in the chat?
Okay.
Hualien. Hualien earthquake. 2021.
Magnitude 5.3 earthquake affected countries: Japan, Philippines, Taiwan, and China 15 kilometers from Hualien City, Hualien County, Taiwan, July 7th, 7:24 a.m.
Okay, so that happened just yesterday. Let's see. Oh. Let's see what else we can learn about this. Oh, I think there's only one article. Let's see. Buildings shook briefly in Taiwan's capital, Taipei, on Wednesday during an earthquake, with no immediate reports of damage. Taiwan's Central Weather Bureau said the magnitude 5 earthquake's epicenter was in the east coast county of Hualien. So when they mean the epicenter,
The point on the Earth's surface vertically above the focus of an earthquake.
So that's what they mean by the word epicenter when they say epicenter. How about a tornado? Have you guys heard of a tornado before?
What
Yes,
is
and
that?
I think, but in Taiwan we call it typhoon.
A typhoon, yeah.
Yeah,
Okay.
we don't have tornado in Taiwan.
So it's called, let's see what the difference is. Tornado versus typhoon.
And even I think I think they in Australia they call it cyclone.
A cyclone.
Yeah.
So what is the difference between a tornado and a typhoon? The difference lies in their size, wind velocity, rate of travel, and duration. A tornado reaches rotating speeds up to 300 miles per hour, travels between 25 and 40 miles per hour, and generally lasts a few minutes, although it can exist for hours. A typhoon, the term used in the Pacific for a hurricane. Okay, Monica, yeah, that's what you said. Right, perfect. Has winds that vary from 75 to 200 miles per hour and moves between 10 and 20 miles per hour, has a diameter up to 600 miles, and exists from days up to during warm, days up to a week. A tornado generally forms several thousand feet above Earth's surface, usually during warm, humid weather. A typhoon breeds in low altitude belts over the ocean, generally from 5 to 15 degrees latitude north or south. Does everyone understand the difference between the two? Or do you guys think they're pretty much the same? What does everyone think? Chloe, what do you think?
I think they are different.
Mm-hmm. And how are they different?
Tornado. Just the size is small, and typhoon is big, and how to say it? Tornado is like a it turns
like a spiral.
Same side.
Oh, the same side.
Quick.
Yeah. So what then do we think or a cyclone would be, or is it the same thing? I don't know. Versus tornado. Let's see. So a cyclone is a huge and powerful storm. A cyclone consists of a low pressure area with high pressure all around. High speed winds go around the center violently and are accompanied by heavy rains. Okay. And they have a large diameter when a tornado has a small diameter. Okay. And diameter is, Gary, you just came from math, right? You said you were in math class?
Yeah.
Yeah. Do you know what the diameter is?
Diameter is a circle, and you can draw the longest line in a circle.
Awesome. Yeah. Thank you, Gary, for that. And on that note, what's half of the diameter called? The radius, right?
Yeah.
Has everyone heard of that before? The radius?
No.
So
I know what is that, but the word is my first time to see.
Yeah. See, so now you know, when you go to measure a circle, right, you go to measure the diameter, but if you measure a point to the center, you also measure the radius, which is the point to the center. And that's how they measure that's how they measure cyclones and tornadoes and earthquakes, right? They measure the diameter and the radius, right? That's something that they use. Okay. So what the video was talking about was they're trying to find ways to help people learn when earthquakes are going to happen, to help them get to shelter quicker, right? Help to get to shelter quicker. So what they found was, what does it say here? So what they said was,
and today, most smartphones are also capable of recording primary seismic waves.
Right? Does anyone, based on what we talked about today, does anyone remember what seismic waves are? Seismic waves? No, we'll look it up. There we go.
We have now we have the alarm.
The alarm. What's the alarm?
Alarm for earthquake on cell phone. They the government will will tell us. But just before when the alarm coming and then earthquake coming, it's almost at the same time.
So is there an application on your cell phone that will give you a notification?
Not the application, just for the government will send the message for us. So we don't need to download any other application.
So you know that you will be safe, and you will be safe in case anything bad happens, right?
Yes.
Good. That's good to hear. Yeah. So I know I've told this to Chloe before, but Monica and Gary, I'm from Canada. That's where I'm from, and we get some tornadoes, but not a lot of earthquakes and like that. So it's very interesting to learn about why these things happen, and I'm glad that there are things in place to keep everybody safe. So if there was an earthquake, where do you think you would go? Like, how do you think, what would be your procedure in keeping yourself safe? What do you think you would do?
First one is open the door.
Open the door?
Yes. And for me, I want to hide next to refrigerator.
Why do you want to hide next to the refrigerator?
If um if the uh, if let me think.
Mhm.
When I waiting for the the survive,
Mm-hmm.
and maybe that is a long day
Mm-hmm.
to wait. So I
Yeah.
need some food
Yeah.
to alive.
Right. Right. You have to be close to
Food
getting a
and
snack.
drink.
Yep.
Yes.
Yeah. So, Monica, do you agree? Would you do the same thing? Would you hide by the refrigerator? Oh, I think she's muted. I think you're muted, Monica.
Now, can you guys hear me?
Yep. Yep.
Very
Yep.
clearly?
Yeah, very clearly.
Okay, I think I agree what Chloe just said. We should open our door, but
Yeah.
at
Yeah.
the moment
Very good
of
idea.
but at the moment of the coming of the earthquake, what we should do is to stay away from the wall or
Yep.
the big furniture, and
Mm-hmm.
hide ourselves under the big table.
Mm-hmm.
And after it stops, in case of the aftershock, in case of aftershock
Mm-hmm.
of the earthquake, then we have to go out for a shelter with our
Yes.
go bags. Every family should prepare a go bag for one member of their for one family member.
Mm-hmm.
A go bag contains all the things you need when there's a earthquake or a typhoon comes.
Mm-hmm.
Yeah, a go bag is a bag contains all the things you need
Mm-hmm.
for
For survival.
yeah, so for survival. Yeah, there
Yeah.
should
Essentials.
yeah, essentials like maybe some food,
Mm-hmm.
candles, and
Food. Yep.
yeah,
Candles. Yep.
maybe some important IDs.
Mm-hmm.
Yeah,
Mm-hmm.
and also the light, maybe batteries.
Yeah. Batteries. Very
Important
good idea. Yeah.
medicines.
Mm-hmm. Medicine.
Like,
Yep. Very good idea. Medicine.
and also like the torch. Yeah.
Mm-hmm. Mm-hmm. Do you have a go bag? Do you have your own?
But I know we should have one in the family, but I don't have one.
Okay. Well, thank you for telling me, because now I can go make my own now, so I can have mine just in case of any emergency.
I think we need to put some water into the bag too.
Water? Okay, Gary says water. We're gonna do water. Okay. How about how about something to read, or maybe like a book or some pictures, or
No,
something.
they are not important.
They're not essential.
Yeah, they are not.
I think maybe can take some pillow to protect
pillow?
my head.
Monica, do you agree?
No,
Monica says no.
a go bag need to be just
Very small.
Yeah,
Yes, compact.
not very huge. But
Yeah.
as a hiker, I had been hiking in the mountains for
Mhm.
for several times,
Mhm.
as long as a week. I
Mhm.
know what we need when we travel or
Mhm.
hike. We don't need anything. We just need the things we need for survival. Yeah.
Right.
Otherwise, we cannot carry them for a long time.
Exactly. Yeah.
To go up go up to the mountain, you need to carry the bag by yourself.
Mhm.
So it's impossible for you to carry the unrealistic things.
Like Chloe's pillow. Okay. So, does everyone feel like they know a little bit more about earthquakes and tornadoes and cyclones today? A little bit?
Yes,
A
thank
little bit?
you.
Gary, what do you think?
I think everyone should have a chance to try if you can think if the earthquake will come and how will it do and how it will happen.
Mm-hmm. Mm-hmm. Very good. Well, Monica, it was very nice to finally meet you today and finally chat with you for the first time. I hope I get to chat with you again in the future. Gary, you as well. Are you guys staying online for the next class? For the next session?
I think I will.
You think you will? Chloe, what about yourself?
Today,
Yeah. Are you going to stay on for the next session tonight?
I think yes.
Okay. Awesome. And Monica, how about yourself? Are you staying on for the next session?
Yes, because yeah, I need to audit more courses. Yeah.
Awesome. Okay. Well, I hope I will get to see everybody again soon, and I hope everyone has a wonderful night. And it was very nice chatting with you all today.
Thank you.
Okay. Goodbye. Okay.
Bye bye.
Bye.
Bye.